This is a mini lesson for absolute value equations, solving them with one variable. So the general idea is that when you have an absolute value of x, we have two cases. So if the absolute value of x equals 5, there are two values that make that true, 5 and -5, because the absolute value of 5 is 5. The absolute value of -5 is also 5. When you have the absolute value of x plus 1 equals 5, there's a little more thinking. We know that this inside must either be 5 or -5, and the values that make that true then are x is 4 or x is -6. -6 plus 1 is -5. The absolute value of that is 5. And then the absolute value of x is -5 is impossible because a absolute value gives us a positive value and we can't have it equal a negative. So when you solve, you always have to have two cases, and I'll show you two examples, and then you always have to check for what we call extraneous solutions, which are solutions that seem like they worked when you followed all of the math patterns, but then don't actually check when you check the solution. So the first thing you want to do is isolate the absolute value. So we want to get this by itself. So the absolute value of 2x plus 1 equals 11 by adding 1 to each side. And then we have two cases. We have the case where the absolute value 2x plus 1 equals 11. We say that this is the case where a equals b. And we also have the case where 2x plus 1 equals -11, because if the absolute value of -11 is 11, then this would also work. So we'd have a equals -b. You don't have to write those, but you could use it to stay organized. When we solve this, we'd get 2x equals 10, so we'd get x equals 5. And here we'd get 2x equals -12, so we'd get x equals -6. The important thing is that we have to check both of these solutions because sometimes both will come out true and sometimes neither will, and sometimes only one will. So we want to check in the original. So we would have 2 times 5 plus 1, all in absolute value, minus 1 equals 10. This is the absolute value of 11 minus 1 equals 10. So this solution works. And then here we would have the absolute value of 2 times -6 plus 1 minus 1 equals 10. So I would have the absolute value of -12 plus 1, so -11 minus 1 equals 10, or 11 minus 1 equals 10. So that also works. That means that we have two solutions. We could leave them separate, or we could write them as x equals 5 and -6, and you'll usually actually see solutions in brackets as a set. Let's try one more. In this case, again, we want to isolate our absolute value. So I have x plus 1 in absolute value equals 2x minus 3. And so I'll have two cases. I would have x plus 1 equals 2x minus 3. And I would have x plus 1 equals -2x plus 3. Because again, we're taking this entire side and we're negating it because we know that we can take a positive or negative in an absolute value and get out our same answer. If it helps you to label this as case 1 or a equals b, and case 2 as a equals -b, you know I'm all about staying organized. So in this case, I'll get my x's to the same side. So I get -x equals -4, or x equals 4. I know I'm doing a lot of calculations in my head. And then in this case, we would have 3x equals 2, so x equals 2/3. Now, because there's an x on both sides of this equation, this is when we could have an extraneous solution. So I went through all of my process of solving, so I think that there's two solutions, but when I check them in the original, we will find out that that's not the case. So I have the absolute value of 4 plus 1 plus 5 equals 2 times 4 plus 2. That is the absolute value of 5 plus 5, so 10, equals 8 plus 2, or 10. Excellent. This side works. And then in case 2, I have the absolute value of 2/3 plus 1 plus 5 equals 2 times 2/3 plus 2. So this is 1 and 2/3 plus 5, and I can write that as 6 and 2/3. On the other side, I have 4/3 plus 2. Well, we'll turn that 2 into 6/3. So I have 10 thirds on that side, which is 3 1/3. And so those are not equivalent, and therefore this is not a solution. It is extraneous. So the only value that makes this equation true is x equals 4. That is the only solution to this absolute value equation. And the reason this happened is that if this had been a negative 1 2/3, then the two sides would be equal to each other. But because it is not, that is not the case. So you always need two cases, and you always need to check for extraneous solutions.